Hello everyone, and welcome to another episode of Sustainable Hart. So first and foremost, my heart goes out to all those impacted by Hurricane Ian and Fiona in the past couple weeks, and especially the 103 people and counting that have lost their lives up to this point concerning this storm. That death toll is expected to continue to rise, of course, as rescue teams continue their search for survivors. First and foremost, there is ever more a clear linkage between climate change and extreme weather phenomenon. Climatologists have stated that there is one commonality among many storm systems that hit the Gulf Coast states in the past decade that sets them apart from tropical storms of the past. They intensify rather quickly and almost overnight in some situations and cases. First, we must consider rising sea temperatures. This is because our water is what fuels these monsters into the hurricanes they are, and those waters are warming due to rising global temperatures. According to this graph, we are seeing nearly a 1 to 2.5 degree increase in average sea temperatures in the Atlantic, Caribbean, and the Gulf of Mexico. What you see off the coast of Greenland is actually impacts from the Greenland ice sheet melting due to these rising temperatures, evidence that the IPCC warned of decades ago. Warmer waters, of course, provide fill for more significant intensification of tropical storm systems at a higher pace, evidence that is now clearer, now more than ever. Warmer waters mean that tropical storms can rapidly intensify from tropical storms or depressions into larger, more powerful hurricanes and typhoons. Take Hurricane Ian, for example. On Monday, September 26, just around 8 a.m., the storm was a tropical storm shifting into a Category 1 hurricane just off the coast of Cuba. Less than 24 hours later, just as the storm struck Cuba, Ian rapidly intensified into a Category 3 hurricane with sustained winds of 125 miles an hour, a massive jump from the 70-mile-an-hour winds it had instilled just over 24 hours prior. Naturally, after a hurricane makes landfall, it is assumed that its strength will decrease to some degree. Although Ian did experience some decreases in its overall strength, it was able to maintain its Category 3 status before intensifying further into a Category 4 hurricane, with maximum sustained winds of 155 miles an hour, another 30-mile-an-hour jump in less than 24 hours. After impacting much of Florida and the Fort Myers area and rolling through Orlando and the St. Augustine area, it was assumed that Hurricane Ian would downgrade into a tropical storm before it made its third landfall in the Carolinas. This, however, was not the case, as the states in the offshore of the Atlantic Ocean had to brace for a Category 1 hurricane. This is an excellent example of a storm undergoing a phenomenon known as rapid intensification. Now we must consider the hurricanes of recent years, such as Harvey, Irma, Maria, Michael, Laura, and Ida, all Category 4 storms that rapidly intensified within 24 to 48 hours. Warmer waters ensure that extreme weather events have the necessary fuel to rapidly intensify into long-lived storms that continue to etch into our memory and deliver billions upon billions of dollars of destruction in the states that they impact as well as the regions across the world. According to recent studies conducted by Stony Brook University and NOAA regarding Hurricane Ian and Harvey respectively, rainfall has been influenced by climate change, temperature increases, and wind shear, decreasing the overall speed of storm systems. For instance, Kevin Reed of Stony Brook University and Michael Werner of the Lawrence Berkeley National Laboratory found that there was an estimated 10% increase in rainfall attributed by climate change to Hurricane Ian. That is further validated by climate model studies utilizing average estimates for ocean temperatures during this period of the year that the storm impacted Florida. This was similar to the devastation wrought by warm waters in the Gulf of Mexico and the 50 inches of catastrophic rainfall from the 2017 Hurricane Harvey, The most significant concern, however, is that this could and will probably be far worse in the future, as a 1 degree Celsius temperature increase in global temperatures can account for almost 7% of moisture evaporation, especially for tropical weather phenomena. This means that if we have a worst case scenario, in which we could be looking at a 4.3 degrees Celsius increase in average global temperatures, then we could also be looking at a 28% increase in average moisture evaporation, meaning extremely wetter storm systems. Our best case scenario is, of course, still an increase of about 1.8 degrees in global temperatures, which means storms will produce more rainfall than they currently do, and they may still be just as devastating. The issue is that we may already have reached that threshold for containment, and we may already be forced to adapt along our coastlines. Now on to our favorite topic: adaptation and mitigation. This topic has been long avoided by many politicians and policymakers. How are we to brace for the potential for more long-lived and destructive tropical storm systems? Perhaps we can make systematic infrastructure upgrades along our coastlines and hurricane-proof the great cities of Tampa, Mobile, New Orleans, Houston, Miami, and Jacksonville, and many of the others that are so prone to Atlantic-borne hurricanes and tropical storm systems from the Gulf. So, we can redefine the transportation sector, utilities, and infrastructure of our coastal cities so that they can withstand a couple Category 3s, Category 4s, and maybe even a full-fledged Category 5. But if this is your answer, then you clearly have not been paying attention. Global temperature increases will bring increased frequency and intensity of tropical weather phenomenon, meaning you will have more storm surges, the same storm surges that decimated Houston and New Orleans in the past, and the same storm surges that are decimating future cities as these global temperatures increase, and the same storm surges that have decimated the coastal regions of Florida with the latest Hurricane Ian. Instead, our aim should be to focus on wetland restoration and developing natural buffer areas along coastlines to provide habitat and absorb impacts from storm systems. I will cover this and the importance of ecosystem services that our coastlines can provide in a future episode, so be on the lookout for that. As always, this is Sustainable Hart. Thank you, and again, please consider making a donation to support those impacted by Hurricane Ian. Also, if you could subscribe, hit the notification bell, and leave a like, that would be tremendously helpful. Thank you, and as always, this is Sustainable Hart.